Welcome. Welcome to the July session of the monthly Lunch and Learn that's been inspired by the KMC Building Geniuses program and series. Today, we're privileged to have subject matter experts that are going to talk about how to leverage indoor air quality sensor implementations in such a way that will optimize and drive facility management budgets. We're going to try to stay to that thread. Some of the questions that could come in might allow us to vary a little bit, but in terms of panelists from Chicago Public School Systems, we have, I want to call him Professor, but it's Mr. Paul Valente. And then we have, again, I want to call you Professor, J.J. Baird from AirThings. So as you know, Chicago Public Schools is a massive school system consisting of tens of thousands of classrooms around Chicagoland. And AirThings is a global company that provides indoor air quality sensors. And then we have from KMC, we have Jesse Schumacher, which is specializing in building automations and the various sensors that support those automations, and as well as the business process and strategy consulting that helps to put a wrapper on some of that. And together, we're going to get through this, and I want to welcome everybody to the call. And before I introduce the topic of what we're doing, I want to go around and first let everyone introduce themselves. So I'd like to start with you, Paul. Please say hello.
Hi, everybody. Paul Valente, Facility Automation Architect for Chicago Public Schools. So been with the district 24 years and ever evolving with what we do from a data standpoint and trying to move the district forward. So thanks for inviting me, Ari.
You're most welcome, and thank you for making the time. I know you're a very busy person. Next, I'd like to ask JJ to introduce.
Yeah. Hey, everyone. Thanks, Ari, for inviting us to participate. I'm JJ. I'm the Vice President for AirThings for Business North America. I lead a really passionate team here in North America that really cares about how do we help the world breathe better. Just a quick background on AirThings. We're the world leader in IAQ and IAQ monitoring technology. We've deployed around 100,000 of our sensors globally, with about 25,000 of that being in classrooms.
Amazing. Lots to talk about. JJ, would you please say hello?
Oh, hello.
I mean Jesse. We'll start with the J. Jesse, would you please introduce yourself?
A lot of J's on the call. Yeah, I'm Jesse Schumacher.
Must be my indoor air quality affecting my cognition.
We'll get you a couple more air exchanges in there and perk you right up. Yeah. I'm the Vice President of Business Development for KMC Controls. I work with a number of our partners that touch our intellectual property, whether they're equipment manufacturers that are embedding our tools, our sensors into their finished goods, or controls contracting partners that are deploying those products in the field, or also I'm a subject matter expert on our TrueFit airflow measurement system.
Excellent. So before we dig into each of your expertise or areas of subject matter expertise, I want to back out for a second and just either ask the question for you to comment on later, or just make the statement that, from my perspective, when we talk about air quality market or air quality sector, we're dealing with air purifiers, we're dealing with humidifiers, ventilation systems, air filters, dehumidifiers, various ways of decontaminating, such as UV lamps, various types of sensors, CO, CO2, VOCs, all kinds of different particles that impact. So I know some of you are going to add or subtract or customize what I just said, so I want and encourage that. It's a large market. According to various research, it's, in the next 2 years or so, it's going to reach about 12 billion in terms of market size. It's growing at a nice rate. And the drivers for growth are obviously getting a little bit of a riff off of COVID. So there's a growing demand just from awareness, the awareness that consumers and other decision makers have about the importance of air quality. There's also government regulations. There's also concerns that have been there for a while about mold, Now there's new concerns about, some of the cyber physical securities that could occur, or events that could occur from bioterrorism. And of course, as the population ages, there's respiratory health. So these are things that, I think about. I don't know if you think about, but my first question goes to Paul. When you think about the K-12 sector, really two things. Number one, the list that I just shared of what this encompasses. Am I missing something? Yes or no? And if I am, what is it? And two, what do you think the drivers are?
So one of the things I would add to the list of the items that you sort of brought out would be pre-existing environmental conditions as well. So as you're implementing technology, one of the things that people don't think about is they want to put the shiny new thing on the wall or install the whatever shiny new thing. And depending on the age of the buildings, such as like CPS, where our average age is about 85 years old, there's pre-existing environmental conditions, whether you have lead-based paint or you have asbestos in spots that have been contained. And so any kind of drilling, coring, or any of those activities, you really sort of have to be mindful of, because that adds cost to the overall implementation and adds complexity as well, too, depending on the nature of what is in the spaces. And then what are we thinking of? So holistically, CPS and I think most other school systems fall into the same sort of general thing of we want to provide a warm, cool, safe, and dry environment. Mm-hmm. And that's sort of the motto that CPS and our facilities and capital team follows. And so to that end, we can't do anything that is exclusionary of any group within our system. Everything needs to be an equitable distribution of whatever we do. So to that end, that's sort of our mantra for how we're proceeding with our thought process. Because, as COVID, during lockdown came up and everybody was figuring out ways of coming back into schools and offices and things like that. For us, at least, one of the interesting challenges was you'll have some higher performing mechanical systems that can take the MERV 13 filters that, ASHRAE was recommending everybody should do. But then we had a lot of buildings that couldn't, have MERV 8 filters. So you couldn't just slap a 13 in there and then call it a day. You would affect the pressure of the system and what you can do at the building. So it's providing an equitable distribution of the response to the incidents that are there. And I like to think that that's what we do.
So that brings up, maybe just to riff a little bit of what you're saying and get back to the core of the question. JJ, what is air quality? I mean, science us. We can handle it.
Okay, perfect. So, when we talk about air quality itself, we're talking about essentially the quality of the air. And there's various things that impact the air that we breathe in. So specifically at AirThings, we primarily focus on indoor air quality. And the reason we do that is because people are now an indoor species, right? We spend much more time indoors than we do outdoors. And the air indoors is usually 2.5 times worse than we're actually seeing from outdoor air. A lot of people have this idea that if I'm inside my house, the bad stuff is outside, the good stuff is in here, and I'm kind of insulated from having to breathe all that in. But the truth of the matter is that couldn't be further from the truth, right? The indoor air quality is generally worse. And I did an interesting thought experiment this week, and I went onto one of these new data image generation sites that AI is now pushing, and I asked AI, generate me an image of an office space or of a classroom that has poor indoor air quality. And it generated this image, and I said, this doesn't make sense. The air quality looks great in here. This room looks really good. And I said, generate another one that looks worse. And it just drew a bigger air purifier inside of the room, right? And every time I said make it worse, the air purifier just somehow gets bigger. And so I think it's a very interesting thing that poor indoor air quality is not something that can be seen, right?
Time out for a second. What are the components of air quality? What are you measuring?
So there's various things, various pollutants that can exist inside of the air. that actually cause issues. So one of the things that it could be is, for example, radon. Radon, completely invisible gas, it gets into our lungs, it starts breaking down some electrons, and that in itself causes cancer if we're exposed to that for a very long period of time. Some of the other ones that just generally make us feel not so great, so we talk about those as more comfort variables, are things like temperature and humidity. So you know that if you're outside in the summer and it's super hot and super humid, you're not feeling great. And if you're inside an environment where you're expected to perform, obviously that has an impact. Or CO2, for example.
Right.
You know, if we sit in some spaces, high CO2, it makes us feel tired, and it actually impacts our thought process and our ability to make certain types
So
of
JJ,
decisions,
before I move on
according to research. Yeah.
before we move on to Jesse, I want to drill deeper though. What concentration levels? Like for example, you mentioned temperature. So what temperature is comfortable? What humidity is comfortable? What CO2 level? What radon level? Talk to us in terms of parts per million, or again, don't hold back.
Yeah, so generally with CO2, we're talking about levels of about 1,000 parts per million.
Okay.
So if we look at the air, look at CO2, it's about 1,000. I think, I just want to pull up a quick report here on my side, but
Please.
yeah,
You're welcome to share if there's anything you want to share.
yeah, so there is definitely something that I can share, but as we kind of go through this, temperature is weirdly enough a very strange one to look at, because a lot of people feel temperature differently. So you might find that two people sitting in exactly the same space might feel like 19 degrees or 68 degrees is super comfortable, where other people might feel really cold in that same one. I think a big one that we look at from a science perspective is more humidity. And humidity we always want to keep within that 40 to 60% range, because number one, it's not just how it makes people feel in those spaces, but it's also related to how it affects the buildings that it is. So if we go above those humidity ratings, we are more at risk for things like mold. If we go outside of humidity rating on the lower side and the higher side, viruses survive better outside of the human body. So there's certainly some statistics that show where do viruses increase the most at which humidity ratings. And I have a really good slide associated with that I can pull up and actually show you.
If you need a minute, I can. There's a question that I've wanted to ask Jesse. It's been drilling in my head. Do you need a few minutes, or do you have it?
No, I'm good to go. Let me just
then bring it
share.
up. Then Jesse, what I have in mind is cost, budget, and cost. So I'll just kind of park that for a second. Let JJ show his thing.
So again, this is just a really quick slide that I wanted to show related to relative humidity and occupants and occupant health. Is you can see sort of that 40 to 60% range where people actually feel comfortable is actually the exact range that certain viruses and fungi and mites and bacteria are not as comfortable, which is really interesting. So by keeping things in this optimum zone, we are really seeing that that's sort of where the reduction of these respiratory affecting things.
That's an amazing slide. I've never seen this presented that way. Is this something you created?
No. This is actually data that came from a study.
It's really nice.
Yeah, so it's from a book called Arundel Anthony v. et al. Indirect Health Effects of Relative Humidity in Indoor Environments.
All right. If you wouldn't mind pulling that, I want to ask Jesse a question. We can come back to anything else you want to share when we go around. Jesse, I'm thinking about end users like Paul and K-12. I'm thinking about offices, semiconductor facilities, data centers, all these places that they want to do something with the outside air. In the wintertime, they want to make it hotter. In the summertime, they want to make it colder. But they want to achieve everything that JJ just said. They want to optimize in that zone. How do you balance the budget? Like, what are the drivers for all this? Are there any 80-20 rules that you have? And could you talk to us about how this all works from a budget standpoint?
Well, I first say that Paul's probably a little closer to the balance sheet than I am with respect to those costs, but We do have some empirical data from KMC's side, nothing that's as aesthetically pleasing what JJ shared. But what we really need to assess is what's the purpose of the facility. If it's for education, then the output, the primary output is that warm, safe, cool, and dry environment for learning. If we're talking about that semiconductor facility that you mentioned, maybe air plays a component, or maybe the just transfer of energy plays a component in the process that is going on within the framework of that building. So it could be part of the the recipe for what people are producing. In the case of any type of like a bakery, where they're going to bring in air and it needs to be of a certain quality before it enters the environmental chambers. Or it could be, a situation where in the semiconductor space, it's primarily used for, the transfer of potential byproducts that need to be mitigated and extracted from the building envelope itself.
Are there any
So,
80/20 rules, though, that drive FM budgets? From whether it's air quality, airflow, various other utilities. There's water, there's gas, there's other
yep.
utilities you have to use, whether you're a school or whether you're a factory.
I would say if there is a 25%, at least with respect to energy management, which is kind of the purview of KMC Controls, it's the identification of deficiencies in the system, making corrections to the existing operation of the building itself, and then obviously an area of concern for us is identification of any areas of improvement for the HVAC systems, whether that's related to the hydronic side or the air side movement of thermal energy.
Thank you. All right, Paul, I want to come back to you for the moment. Like you, and like all of us on this call, I like to study, and I recently studied a survey. There was a partnership between Fellows Corporation and a nonprofit called We Are Teachers, and they polled about 2,700 K-12 educators about indoor air quality just in U.S. schools. First of all, are you familiar with that study?
Yeah, it was a very interesting study. But yeah, go ahead.
And so my question is, I had certain takeaways, but in the context of our conversation here, whether it's improving or decreasing absenteeism, improving test scores, or I don't know, whatever the metric might be.
Yep.
What did you pull from the study? Because I want to establish the relevance of managing indoor air quality from a standpoint of, for example, that study.
Yeah, good question. What I pulled from the study is something that we've sort of innately seen with perception versus reality in certain spaces. As JJ was mentioning earlier, about it, for the question of like what is indoor air quality, I sort of joke that you shouldn't be able to see air. If you can see air moving, then you obviously have something in the air that is moving around, and you should not be seeing that. So it could be
Going
dust or
back to
light.
JJ, if you see fist-sized particles in a semiconductor fab, you're definitely nervous.
Yeah.
They start doing figure eights and dancing around the room. You go, oh boy, I need JJ to measure that.
That's yes. Well, yes. As soon as you start saying anything or that way, but I think holistically, and this is something that it probably transcends beyond education and others, and it's more for occupancy, for in general occupancy is some misnomers that people have around air quality, and the biggest one is, with complaints around like headaches or things with virus loads and such. And so you have to look at like how the space was designed. It's much to like what Jesse was talking about is utilization of the particular space. So in education, you're typically in a locked in environment. So your students are all going to be coming into the space along with their teachers, and they're going to be in this space for a very long time. And that differs dramatically from like retail, where your staff are going to be locked in, but your general occupants are going to be more transient in nature. And so that sort of dictates the different types of strategies that you're going to employ to treat the air for the spaces. Maybe you're rapidly cycling, and trying to get your air exchanges up a lot higher for more transient population. Or like in our case, we're trying to meet ASHRAE's requirements We are meeting ASHRAE's requirements or exceeding it because of Chicago Building Code's requirements for ventilation in spaces. But a lot of it boils down to is people don't think about holistically, or not that they don't think about it, I should refrain. There should be more of a frank conversation of how the operations of the particular schools work, especially around air exchange rates and air purification and methods that go into just monitoring a facility. Great example. One of the challenges we run into from air sampling is people will burn candles in spaces or put air diffusers in, and so that's commonly releasing PM particulates, into the space. And then you're releasing other gases and such, especially with combustion. Then you do some things of that nature. And while it might be pleasing to the person who puts that on, maybe the teacher or whoever the person that's there, that could dramatically impact the air quality for somebody who's maybe asthmatic, where that will trigger a lot of that kind of stuff.
Amazing.
The other big thing I just wanted to highlight too is the big struggle that folks have recently with the youth with vaping. While vaping, for all intents and purposes, might be a little less obnoxious than traditional combustible smoking from releasing smoke and things like that, which obviously neither should be done in a school building or in a government building. But sometimes people put a pass to vaping. Oh, it smells like blueberry pie or something like that. Oh, how bad can it be? There's a lot of things that are being outputted in that exhale that then can affect others, from their respiratory health.
So JJ, how quickly can whether it's your sensors or sensors in general respond to that change, whether it's in a classroom, whether it's in a bathroom, a common area like a hallway? How quickly can you respond? And do you find there's a correlation between how kind of what you measure in the air and how quickly you measure what's in the air to managing budget? Like, do you find, so two questions, how quickly can you measure it, and is there a correlation?
So the response times for indoor air quality sensors are generally really fast. So the time from where the data starts changing to the time where we detect it is almost instantaneous. The way that we report that data might not be as fast. So depending on what the needs of the customer is and how the customer can actually respond to these changes in the short amount of time, you're looking at anywhere from 2.5 minutes to 5 minutes to 10 minutes, 15 minutes, 30 minutes, 60 minutes, depending on what the customer actually requires and what the actual thing is that the customer is measuring. So things like things that would require additional ventilation, especially when it's integrated into something like a BMS, we want those much quicker normally because we want the automation to kick in and actually do something about it. In the ones where it does require human intervention, where there isn't necessarily some sort of BMS that can solve the particular problem, because it does require some investigation first. Because you can't just throw ventilation at everything, right? If you let's say you've got something that's generating a whole ton of VOC in a particular room, and your automation just goes, okay, let's just pump more and more and more air into the problem. We're actually just wasting energy at the end of the day. And those ones that require intervention generally is a little bit slower and a little bit lagging than the more real-time.
I feel like Jesse is ready to jump out of the screen. And go ahead and riff off that, Jesse.
I feel like he hit the nail on the head. It's just delivering the code minimum amounts of outside air. That's one of the key components. It just ties the the control and remediation of indoor air back to energy efficiency.
So have you developed some rules? I mean, Jesse, have you felt that, have you achieved, the holy grail of optimizing the consumption of electricity to achieve some of the goals that, an end user like Paul might set for you? And then through JJ's tech, he can help enable that?
Well, at least as it relates to, indoor air quality, ventilation or air exchange rates, whatever you want to call it. It's the cornerstone of any indoor air quality strategy. But again, the key, getting back to kind of what JJ was saying, is that just being able, being able to fine tune your system to deliver the code required minimum of outside air is key. We see a lot of facilities that are over ventilating their spaces, whether that's intentional or not, based on some established standards that were created when the building was originally commissioned. And what we find is that I'm gonna reference a stat that I know for Paul here. When your buildings are approximately 60 years old, the quality of the seals, whether that's on the building envelope itself or on the outside air dampers or the louvers, it's going to change over the course of time. And without commissioning, retro commissioning, and consistent monitoring of how much air is actually coming into your building and accounting for the potential leakage, we see a natural tendency to overventilate those spaces, and that leads directly to energy implications. On the order of anywhere between 20 and 40%, just dependent upon how poorly managed or how aged the systems are.
So I want to build off that, but I want to ask a question to the group, and any one of you, if you don't, I think one of you will pick up naturally, but if not, I'll ask specifically. I'm thinking about the air quality sensors. You have them in a room, let's say it's a classroom or it's in an office and so forth, and you get that response rate, good. And that signal telemetry goes into some building management system, good. And then there's rules, good, good, good. But you mentioned something a moment ago, Jesse, the louvers. Okay, so I'm thinking, are there sensors inside the ventilation? Where else should there be sensors? So in general, if you could somehow have a magic wand of an infinite debit card and put sensors wherever you think sensors should be, and get the response times optimized so that you have the perfect use of indoor versus outdoor air to achieve the set points you're looking for in that space. Okay, would you put sensors everywhere? And A, and B, what is kind of best of breed that you're aware of people who really measure everything in their environment, including air quality, but including even maybe the seal strength or the angle or how quickly air is moving, the velocity of the air in a ventilation. So A, should it be done? And B, are you aware of a best example? So I put it to the group. Anybody want to volunteer?
I'll jump on that first
Please.
if nobody else has anything to go with. If we had the unlimited debit card, it would be nice to have sensors everywhere. Unfortunately, the reality for us, at least, is we have 55,000 rooms in addition to hundreds of buildings. So it would be prohibitively expensive.
How much square foot is that, Paul?
It varies depending on how people calculate it, but roughly around 65 million square feet.
Wow.
Yeah, so 800-ish buildings, including outbuildings, we're about 1,100 physical structures. So we're a pretty large landlord. But if you just take a step back from that and you think about it sort of holistically from an educational standpoint, and this goes back to sort of like just general and financing and such, K-12 is never going to have that kind of funding unless you have some real massive influx of funds that come in or there's a very specific need. So, and then in reactionary funding, yes, you might have that. So, we see in various different events that happen, large scale horrific things, then there's a reactionary kind of thing to let's invest in protections around certain things. When it comes to indoor air quality, we tend to at least do more of a blended approach. So looking at choke points, looking at essential rooms within the buildings, areas where we know there's going to be a lot of occupants for a long period of time throughout the day. Mm-hmm. Those would be the places we target with a permanently installed solution. But I think that sort of dovetails together with what the SOP would have to be for the organization, because you can't just do full permanent installations and call it a day. You have to have sort of a blended continuous testing environment, and then that's where you would have more portable solutions. So handheld IAQ monitors with a procedure to interpret the data and then blend that and then extrapolate on it, especially when you're
in a school environment. You probably could have, gifted juniors and seniors be kind of IAQ ambassadors.
Well, double-edged sword. So the problem also with a IAQ is certain aspects of indoor air quality monitoring require certain amounts of dwell time in the particular space in order to capture properly. Being understanding where to position the sensor to accurately capture for that particular stuff. Go back to vaping and THC detection, which we're doing a little bit of within CPS. There's a specific way to mount the sensors that can capture that, as opposed to just capturing general IAQ, because you have differences in the sensor types and calculations around it. So it goes back to it depends, but I think holistically, something that K-12 and higher ed needs to think about is strategically placed, permanently mounted solutions, whether it be a mixture of in the spaces, but then also a mechanical, and then also having a response plan and a defined SOP around environmental procedures for spot capturing and an escalation procedure that way.
So anybody else, JJ, Jesse, you want to build on the same question?
I mean, we would obviously, as an indoor air quality monitor manufacturer, we would love to see indoor air quality sensors being mounted in every single space in every single room. And there's definitely a discussion to be had related to what the ROI is from very large scale implementation of IQ. And we're seeing customers go beyond just the standard IQ monitoring in just the common spaces. We're now also seeing customers put it into spaces that are unoccupied, but maybe sensitive to some things related to mold. Like, for example, they're storing certain types of things. What's actually going on in those rooms, or what's going on in my attics? What's going on in parts of my ductwork system? And is the conditions ripe for things like mold? Could there be other issues that are developing? Am I seeing pressure variations? All kinds of things like these that could cause long-term issues that, if they're not picked up earlier, could be a much larger cost. Generally speaking, the cost of IAQ has been coming down and down, especially with mobile or remote IAQ monitoring solutions. And so the cost of remediation versus the cost of monitoring just sort of is starting to make more and more sense for customers. And, we can go back to, the discussion related to how that ties into budgets.
Right, because I'm wondering about two things. Number one, the break even. Are we talking about 6 months or 6 years or something in between? And number two, again, I want to know if you can share an awesome implementation where they did it right. They had a current state. They said, we got to fix this. They put in a remediation, and now they have a future state that they paid back in 6 months or something.
Yeah. So generally, as you mentioned, the first step for any customer to do is to sort of get a baseline. Understand what it is that they need to fix and where it is they need to fix it. I think if you're fixing problems without knowing what the indoor air quality is, you're doing something wrong. And I think we saw a lot of this during COVID, where a lot of schools just started doing air purifiers, and they started putting air purifiers literally everywhere in every single classroom. And my question always sort of went back to this thought of, but why? Is particulate matter the actual problem that you're having? Are you sure that it's not a ventilation issue related to CO2 and you're not pushing enough air into these spaces? So it's always kind of boggled my mind that people try to solve problems before they even know what problem they actually have.
You get whether it's your own body or your building, you got a baseline.
Yeah. And that ties then into that discussion of data-driven decision making and how does this drive my actual budget? Because now if I know what the problem is, and I can visually see it, and I can back it up by data, going and asking for funding and saying, how do we solve these problems, is actually backed by actual things that are happening in the spaces that we actually have. And we generally see, it depends on how detailed the customer does the implementation. And as you've mentioned, I can't really mention any specific customer, but we have some customers that have implemented in excess of 20,000 sensors in all of their buildings globally. And they're certainly seeing ROIs far beyond just that can be calculated, because the ROI of indoor air quality and human performance is sort of very interlinked with one another. So, based on all of the studies, we can see that there certainly is a huge level of performance increase that we see with better indoor air quality
Sure.
environments versus worse. And there's various studies, and we can go into the details of some of those studies.
Jesse, you've been quiet, and I know you have so much experience and so much data. Is there an example that if you can't share it specifically, maybe in general?
Sure. I can cite there's a university that's close to KMC's headquarters in Goshen, Indiana, that went through a pretty extensive overhaul of their energy management, at least as it relates to HVAC systems. And I think that is the underlying theme of this entire conversation, is that baselining. And when they reviewed where they were, the college was however many years in operation with existing systems that were 20 to 30 years in service, they saw massive opportunities to upgrade from some of the older technology, some of their direct expansion unit for cooling, to centralizing the water utilities, and then changing from chillers and boilers exclusively to incorporating geothermal and power generation on site, and all of that wrapped around the opportunity to vary the air volume rates and schedule occupancy hours to really create not only an energy efficient environment, but also one that produced high indoor environmental quality for the students that are enrolled there. The payoff, though, I think is what you're really driving towards, and they were able to show a reduction in energy consumption of 38% within a 5-year window. So the return on that investment was relatively immediate when you think about just the longevity of those structures themselves.
Amazing.
Can I add another point I wanted
Yeah,
to
go
kind of
ahead.
add to the
Yeah, make your point, because I know there's so much kind of popcorn bursting here, but then I want to ask one final question to all of you. Go ahead.
Yeah, and this aligns, like, I guess, with the financial comment that you made earlier. So there's other ways to think about it, of how you can finance these devices and technologies beyond just pure IAQ monitoring initiatives. If you look at broadening, the silo that normally IAQ lives in, to maybe just conjoining it with BMS, and then potentially taking, like, what we're working to do is take our IAQ sensors, put them into our BMS specification in lieu of your traditional temp, humidity, and CO2 sensors. So now you have a mechanism through capital investment and reinvestment and redevelopment of our sites to then roll out the sensor and sensor stack, in addition to your traditional IAQ monitoring efforts. So there's a couple different ways. Other one that I just want to highlight is, like, at least in Illinois, there's a House bill that's making its way through General Assembly, that's still going, and Jesse is aware of this, that is going to be looking at bringing IAQ monitoring to all schools within the state of Illinois. It doesn't have funding attached to it yet, but there's going to be creative ways that we can look at bringing funding to it and aligning other aspects of what these IAQ sensors bring from a sensor stack to merge sort of initiatives across the district.
So one reference point for you, which you're aware of, is the public partnership between the CDC and the state of Colorado to do those kinds of things. So it might be a good access point for you. I know we know some of those same people.
Yeah.
So I want to ask this question to everyone here in our final few moments. There's like a gap from my perspective between kind of what people want to do, how they spend money on their respective facility in whatever sector they're in, versus what they have to do. So the question is, A, do you believe that there still exists a gap between whatever stakeholder and whatever authorities regarding the prioritization of indoor air quality? So number one is there a gap? Number two is, can you think of an example how this gap is being navigated in a way that might be either helpful or somehow inspiring to some of the people in this audience? So maybe in this case, I wouldn't mind start. Well, I don't want to put anybody on the spot. Who wants to tackle that?
I got a thought.
Okay.
So I'll jump in first here. And this is, just referencing some of the conversations we've had with other commercial real estate property holders. A lot of their concerns are tied up with net operating income. which may or may not include indoor air quality. Quite typically, they do not. They're concerned about having their spaces utilized and occupied, meaning
And getting the most rent.
rent rates. Yep. So, indoor air quality does not always tie into that. However, there's been some, especially since COVID, influential organizations such as Reset, Well, Fitwell, that have, and even the U.S. Green Building Council, that have generated, some standards and some accreditations that building building owners can achieve through the implementation of successful indoor air quality strategies. And I have heard anecdotally that some buildings, if of similar size, similar geography, have been able to command an additional 20% for rent rates, just based on the fact that they've achieved that level of certification.
Thank you. Paul?
Yeah.
JJ?
Yeah,
I'd
we're
further-
certainly seeing exactly the same thing. It's sort of that gap between building owners and building occupiers or renters. And we're seeing it sort of going both directions, very similar to the direction that Jesse has been talking about, which is, there is hybrid work is certainly a reality. It's going to become more of a reality. And so there's more space available than people are willing to occupy. And so how are building owners actually differentiating themselves from another building that in essence is exactly the same? And one of those differentiators have been indoor air quality as one of them. One of the ones that come from the other side of it, from the tenant side, is we're seeing more and more tenants write indoor air quality into their lease contracts, requesting that the air needs to be of this quality, and there's actually some penalties to the actual building owner should these levels not be maintained. So certainly a cool way to bridge that gap. I think other gaps exist between sort of the facilities team and the team that works on workplace experience. So certainly, facilities has a certain goal. They want to keep everything up and running. And the workplace experience people, they want to sort of make sure that the whole experience from the point where you come in is really good, and the air quality needs to be of sufficient value. And we're seeing some companies that are doing a really good job at bridging the gap between those two by having intermediaries and figuring out between the two teams, making them more integrated in terms of how do we offer the optimal workplace experience to employees, to kids, things like this.
Before you make your comment, Paul, I will tell you that in November, on the fourth Friday in November, we're having that exact conversation. And how do you, because it's brilliant what you just said, and we're having the conversation with two of the largest, influencers on this from a nonprofit standpoint, which is IFMA, the International Facility Management Association, and with BOMA, Building Owners Management Association, and with CBRE. So we're having that conversation in November. It'd be amazing for you to be part of that audience. But Paul, I don't want to take your time. Go.
Oh yeah, just real briefly. I mean, a couple things to think about too from like the K-12 space. And while we're not necessarily like general property, we're renters or something to that nature. We do rent some property, but we do have rentees that rent some of our properties, and we haven't seen yet needs for IAQ monitoring yet in the contracts, but we feel that's going to be coming. But some of the things that have been interesting to see as we've deployed indoor air quality monitoring, and this is something we've been talking with our property team on, is where people are violating rules within the particular spaces that they're renting from us. So government institution is harping on vaping. There's no vaping allowed, no smoking allowed, obviously. But we've seen through our IAQ monitors when there's breaks or gaps in the programming for the renters of some of our spaces that they go to the bathroom and start vaping. And
Amazing.
That by having that, then that can empower our property management team to then hold those attendees accountable that they should not be doing this and potentially levy fines. But at the end of the day, for us, while the focus might not, from our capital team, might not be 100, like we need to provide good and safe spaces, warm, safe, and dry and cool spaces. IAQ is a component of that, but there's grander things. So I think it's tying back IAQ to a number of other verticals to align that, so that way you have not just IAQ be the focus, but it be a component of a grander focus,
Thank
when
you.
doing development projects. So
We're at the top of the hour. I want to close by mentioning three things. Number one, I'm grateful. Thank you for making the time to have this discussion. Your subject matter expertise is obvious. It's been obvious to me for a long time, but now to the audience. Number two is just interesting anecdote for you all. About 2 weeks ago, KMC was contacted by one of the largest owners and operators of commercial real estate to say, we need some help analyzing what we have. We have, we kind of like needed an adult in the room to objectively look at things, because we're collecting information on weather, on air quality, on who's using our parking lots, who's coming in the building, what rooms are occupied and not occupied certain times of the day, when there's fire alarms hit, when there's safety incidents. Like, we have all this data, this like structured and unstructured data. Could you find some breadcrumbs and be a detective and follow those and see if you can, come up with a conclusion to say, oh, this is related to that. So I wanted to let you know that we're in the middle of that right now. So that's cool. The third thing I want to say is, to close out, we do these every month. We do these on the fourth Friday of every month. Next month, in August, in particular on the 16th, on Friday, August 16th, at 12:15 p.m. Eastern Time, we're going to have the most enjoyable and informative discussion on best practices in cyber physical security, operational technology, site assessments, and remediation. And we're going to have on this call the former CIO and CISO from CBRE. We're going to have the head of the cyber physical security practice at Michael Baker International. We're going to have the head of partnerships globally for Ruckus CommScope. And it's going to be hosted by Tim Vogel from KMC, who is the head of the KMC Commander platform. It's going to be an enjoyable discussion. I think it has big shoes to fill based on this one, but we'll see where it goes. So with that, I want to close out and wish you all a safe, enjoyable, healthy weekend.